All right, we're back. We're on page 73 in math analysis, which is in the middle of note 7. And we were talking about verifying identities. We're still talking about strategies for verifying identities. So we've gone through a bunch of them. I don't think I remember them offhand. It's like, I mean, I could just look, but I'm going to try to remember. Write the problem correctly. Work on the complicated side. And I don't know, like break up fractions, combine fractions, and then distribute, I'm guessing, because number 6 here is factored. So I think those are the 5 that we have so far. And you need to do a lot of practice problems, really. So I tried to do one of each strategy so far, except for like writing it correctly because they're typed. And you need to find more problems that you can do on your own. One of the things that I like to do is I just go to like books.google.com, and then I will type in verify trig identity or trig identity, and it returns like the free samples of the textbooks that are out there, or some textbooks are just free. It returns those, and you can see the problems that are in it. And so I'll do the problems there. That's how I get a lot of practice problems, actually, that I end up doing. So that's a little tip for you too. So strategy number 6. So remember, we're never crossing the equal sign. That's the golden rule of verifying identities. And we do that because it's not like you're going to run into like this thing and somebody says like, is this an identity? No, you're going to run into the left-hand side, which is very hard to work with. And you'll look at it and you'll be like, maybe if I turned it into something else, it'd be useful. Ultimately turn into the right-hand side, and that's useful. So that's why we don't cross the equal sign. So let's see if we can do this. So try to factor if it looks like it will work. It looks like I can factor this because this is a sum of cubes. Sometimes I forget that you can factor a sum of cubes because like you sort of can't factor a sum of squares. So I feel like cubes should be the same, but it's not. So if we want to factor, let me over here, if we have a cubed plus b cubed, that's going to factor into, so I either use synthetic division. I just like guess one of the, like if b equals negative a, then blah, blah, blah. But when I just want to remember it, I use SOAP, right? So it's going to be the cube root of the first thing, then it's the same sign. So that's what this is. So it's going to be plus the cube root of the second thing. So this plus is that. And then it's going to be, so you do have to remember like what to do, and the word doesn't tell you, but it's square the first. Now you multiply them together, and it's the opposite sign. So it's going to be negative AB. So that's where the opposite is coming in. Opposite. And then plus, because it's always a plus. So that one doesn't have like a cool thing for it, but always a plus. And then you have to square the last one. So I'm going to use this. So it's the same sign, the opposite sign, always a plus. I could never remember that. And then my students told me that 1 year, like not as long ago as you might hope if you're me. So I'm going to factor this. So A is basically sine, B is basically cosine. So this is going to be sine, so that's the cube root, and then it's going to be same sign, so plus. Another tip off, but well, let me just do it. And then square the first thing. Multiply them together, it's the opposite sign, so minus sine, cosine. I'm a big believer in however you choose to remember things, remember them. Like some people will be like, don't use SOAP, understand it. Like I've always understood it. I could never remember it. But now I can remember it. So those people can just get out this and then all over, just all over sine plus cosine. All right, good. And I'm just going to write equals because I don't want to accidentally cross the equal sign. So I'm just writing equals. Now this, you can see you're going to end up canceling this and this. Now the thing that I was going to say when I like started to say something, I was like, no, don't do it. If you don't know what to do at all, you can cheat and look at both sides, right? So on this side over here, there's nothing in the denominator. There's just 1, right? It's not a fraction, which means that when you're working on this side, somehow this must cancel out. If this is going to cancel out, it means that this is a factor of the numerator. So like, even if you didn't remember how to factor, you definitely would want to start with this. Once you start with that, you got a sine, you got a cosine. Well, what are you going to multiply sine by to get sine cubed? It's going to have to be sine squared. And then you got a cosine, and you need to end up with cosine cubed. So this is going to have to be plus cosine squared. And then you're like almost there anyway. But you're like, well, what's the other thing? What I know there's got to be more to it because it's not just sine plus cosine times sine squared plus cosine squared. There's got to be that middle term. If you can't remember that, now cheat and look at the other side, right? So I see a sine squared plus a cosine squared. That's a 1. Well, there's already a 1 there. The only other thing that's there is this, minus sine cosine. So I would, at this point, just put in minus sine cosine because it needs to be there. So that's how, like, when you don't know what you're doing and you look at the entire problem and get a sense of like the form of it and like what should be equal and things like that, you can do a lot with a problem, even if you like walk into it not knowing what to do at all. And so like never give up. Just look at the problem, see if there's something you can do. Can you borrow the shape of it from the other side? Is there a fraction, and how do you get a fraction? Is there not a fraction, and why not? These are all things you need to think about. So now what we're going to do is, you don't need to show putting these next to each other. Like we got sine squared, we got plus cosine squared. That's going to be 1. So 1 minus sine cosine. Gosh, I don't know why my x's are weird here. Sine cosine. There you go. So when you're done, I draw a box and then I shade it in. You don't need to shade it in. You should draw a box though. That's if you look at textbooks, you'll notice that they do that. They don't like point it out. So the really, really super pretentious way of saying that you're done with a proof is to write QED, which is like, I think it's like quad erat demonstratum or something like that which was to be demonstrated. But that's pretentious. People don't really do that anymore. People just put the box and kind of move on. Unless you're being pretentious. When you're arguing with somebody and you think you've made a solid point and there's nothing that they can say to ever change your mind, you can really annoy some people by like, you say your piece and just go QED, and then they'll say their thing, you repeat it and go QED. It's really obnoxious. So I'm not advocating that you do that. I'm just letting you know that like, it's a thing. So should I do these? I'm gonna, I don't know how long this has been. I'm gonna start it. All right, so strategy number 7 is one of my favorite strategies because it's a little bit weird. Are we doing a highlighting thing? I was in the last video. I don't remember. All right, so strategy number 7 is multiply by a very clever form of 1. So, well, it just says a clever form of 1, but they're all very clever. So that might mean multiplying the top and the bottom of a fraction by like sine over sine, right? Multiply both the top and the bottom by the same thing. That's 1, right? Sine divided by sine is 1, but it changes the way things look. So what I want to do is show you the most common weird versions of 1 that you're going to be using. And to get those, we need to rearrange and then factor these Pythagorean identities. We're going to get what are called Pythagorean conjugates. And let's see if we can, let's just do one, right? So here I see that sine squared equals 1 minus cosine squared, right? Just subtract cosine squared from both sides, because we know that this is equal, so we can do that. But then this factors. So sine squared, this is a difference of squares. 1 minus cosine, 1 plus cosine. So when I'm doing identities, I sometimes don't put parentheses around the x's, like cosine of x, because it's just so many parentheses. It's the only time you'll see me doing that. This is a set of Pythagorean conjugates. So I'm gonna highlight them. These are Pythagorean conjugates because if you multiply 1 minus cosine, 1 plus cosine, you end up with just sine squared. You can just jump to it. Like it's gonna happen every time. It changes its form. So the other place you've probably seen conjugates, I'm gonna guess is with complex numbers, complex conjugates, like 2 plus 3i, 2 minus 3i. They're conjugates. You multiply them together, you get a real number. It changes from a complex number to a real number, changes its thing, right? Here, If we multiply 1 minus cosine and 1 plus cosine, it changes from cosines into sines. It changes its thing. So that's why they're called conjugates. So I'm gonna do the other one, and then I will cut this video and come back and finish this box, and then probably finish the page. Who knows? We'll see. So the other way to do this would be to say that cosine is 1 minus sine squared. Also, I keep forgetting to say squared. Cosine squared is 1 minus sine squared. And then same deal, cosine squared is going to be 1 plus sine and 1 minus sine. So I would say of the Pythagorean conjugates, these are like far and away the most common. So if you see, so here's the idea. If you see 1 minus cosine, then it's almost always a good idea to multiply it by 1 plus cosine, but you can't just do that, right? Because that would change, that's doing one thing to one side of an equation and not the other, and that violates algebra. The way you get around doing something to both sides of an equation is you multiply one side of the equation by 1. So you multiply by 1 minus cosine over 1 minus cosine. That's 1, so it changes the way it looks, but not its value, and you didn't break the golden rule. So that's where we're going to end up using these. I'm going to be back in the next video, finish these, and then, I don't know, keep going. So I will see you there.